Now let's take a look at the different types of volume, that the two types that we have, the SDF volume and as well we have the fog volume. So let's see that. So in here, let's create a geometry node and type inside. And in here, I'm going to create a rubber toy geometry. So let's add this. And now let's convert this into volume, and I'm going to convert this into VDB volumes because VDBs are more efficient because they are sparse. So let's convert this into VDB volume by adding a VDB from polygons node, and let me add this and connect this. And in here we have successfully converted into volume, and by default VDB from polygon node will convert this into a SDF volume, and that is the SDF representation of our geometry. And we are naming this our volume to a surface volume. And same way, if you want to convert this into fog volume, you know that we need to just enable our fog VDB as well. Now we have both of them. Let me uncheck this distance VDB. And now here you can see we have the fog volume. And the fog volume is used to create the volumetric type of effect. For example, creating the clouds or the fog, or for example, the smoke simulation or explosions. All of them are fog volume. And the SDF volume here, the surface representation, we can use the SDF volume to create all sorts of geometry operation. For example, we can use the volume modeling techniques to use the volume to create a more complex Booleans operation, the combination and extract subtraction. Let me show you what I mean. Let me lower this down to, let me first increase the resolution. So which means we need to lower down the voxel size. So let's lower this down to a value of maybe 0.01, sorry, not 0.051, but 0.01. And here as you can see, we have a much higher representation of our geometry, and it is a volume. Remember that it's not a polygonal piece of geometry, which means I cannot have access to its primitive because we do not have any primitives, and the points, we do not have any points because we are right now working with voxels, and inside of the voxels we have the information. So where we have the geometry, where we have the polygons, the voxels will get a value of 1, which means we have geometry in here, and we are visualizing them as this surface, but it's a volume. And to actually convert this back into original polygonal piece of geometry, to convert this into polygons, we have a node called convert VDB. So let's add a convert VDB node, and let's connect this, and let me add this in here and view this. And by default, the convert VDB node will convert your incoming volume into Houdini volume. And here you can see we have the convert to option to volume, which means that we are converting this into Houdini native volume. And if I were to middle mouse button, and here you can see we have one grid volume. One grid volume means that the Houdini native volume. And before the convert VDB into the VDB from polygons node, here you can see we have one VDB volume. And this convert node is converting back into Houdini native volume. We can also change its parameter, and we can change this to VDB. Let's say if we have the incoming volume, the Houdini native volume, for example, the volume that is coming from the smoke solver, when later we are going to create the smoke simulation, smoke solver will output Houdini native volume, and we can use the convert VDB to convert our incoming Houdini native volume into VDB volume, or we can convert this into polygons. So let's enable the polygons option, and now here you can see we have our polygonal representation. It's not a representation, actually it's an actual polygonal piece of geometry. And if I were to middle mouse button, and here you can see now we have the points and primitives, which mean that we have the actual geometry. Now I can able to select my individual points. I can activate my primitive and select all of the primitive, the edges. And here you can see we have this polygonal piece of geometry. And because we are in here working with volume and we are converting this back into polygons, Into the volume, we can use these VDB nodes. If I type VDB, and here as you can see, we have quite a lot of VDB nodes to create all sorts of different operation with the volume. And first, let's create the Booleans type of operation, the SDF. We can combine multiple volumes, we can subtract them, and let's see how we can do that. First, I'm going to, let's say I want to punch a hole in my this rubber toy. And for punching the hole, first let's create a geometry. And for that, I'm going to use a cylinder, and cylinder is called tube inside of Houdini. So let's add this, and let me view my this geometry. And in here, let's add the end caps to add the end caps at the end. So let's enable this. And in here, let me enable the columns to add more resolution to create more smoother surface for this geometry. And maybe let's lower down its radius, and I can increase its height to create a longer. Maybe let's increase its height to value of something 2.85. And after that, we need to convert this into volume. And for that, let's add a VDB from polygons node, because we have the polygon as an incoming geometry. So let's add this. And now we have successfully converted this into volume. And let's lower down the voxel size. I'm going to lower this down to a 0.01 to add more resolution. Now we have these two volumes. We have this VDB from polygon, this rubber toy, and this cylinder. And to actually combine this, we have a node called VDB combine node. So let's add a VDB combine node in here. And in here, I can use the A VDB, that is the VDB A, and I can convert this the second input, and that is our VDB B volume. And now let's view the VDB combine node. And in here, as you can see, right now I am not combining them. It's just outputting this VDB A. So let's enable the parameter of this VDB combine node. And in here, we can change the operation. So let's click. And here as you can see, we have quite a lot of operation. We have these Boolean operation. So it is written in here. It says SDF union. So which means we can combine both of these SDF volume, this A volume and the B volume. So in here, I can change this to SDF union. And here as you can see, we are uniting both of these volumes. And I can also change this to SDF intersection. And now where we have the intersection, we are only outputting the intersection volume. Or I can change this to SDF difference. And that will just create the difference. And it will actually, as using the SDF difference, we are basically subtracting this VDB B from this VDB A. So in here, maybe let's add a transform node to let me adjust the position of this cylinder. So after that, we have converted our volume. I can add a transform node. Let me view this VDB combine node, and in the node editor, let's select the transform node. And when the node is selected, hover over to the viewport and press enter so that we have this handle. So let me move this tube of this cylinder. And here as you can see, I am punching hole where we have this volume. And I can even rotate this. So let's rotate this, our box. And we should have this, our hole. I can move this around. And I can increase the radius. Let's increase the radius scale. Okay, that is a quite big radius. So to snappier interface, maybe let me lower this value down like so. Let's go into the VDB combine, view this. Now we have this much bigger hole. And now we can convert this back into polygon by adding the convert VDB node. So let's add a convert VDB, connect this, and onto the convert VDB, let's change this to polygons. Okay, so now we have the polygon representation over this polygonal piece of geometry. And to hide the wireframe, I want to see this my smooth geometry. So let's hide this wireframe. Let's go in here and change this to smooth shaded. And here we have our this polygonal piece of geometry, and we can also add some other operation. For example, if I go into the VDB combine, I can change this to SDF union, and here you can see now we are uniting both of our geometry, and it is uniting them accurately so that we do not have any weird geometry uniting that we can get with the basic Boolean operation. So which mean I can, if I zoom in, if I go inside of this geometry, and here as you can see we have these holes accurately. We have punched this hole accurately. Sorry, we are not punching the hole, we are uniting them. So let me zoom in, and here as you can see we have this union pretty accurately, and we are not getting any types of weird artifacts in our polygonal piece of geometry. So you can really create your crazy complex geometry with these volume modeling techniques. I can combine multiple pieces of geometry. For example, let's add a pig head in here. Let me add the pig head, and let's connect this into this VDB from polygon node, and let me lower down the scale. I'm going to, let's change this to a half value, and on the transform node let's adjust its position and rotate this, and let's go into the convert VDB node, and here as you can see we have this combination, we have the combination of both of these geometry flawlessly, and it's working as if we have modeled them like that. So you can actually create crazy complex geometries with these volume modeling techniques, that is called the volume modeling. And after that we have some other operation. For example, we can smooth out our entire this SDF. So if we type VDB smooth, and here you can see we have these two smoothing operation, VDB smooth and VDB smooth SDF. Because we are working with SDF volume, so let's add an VDB smooth SDF, and where we have the VDB combine. So after the VDB combine we are in the volume, so we need to connect this in here and view this, and here you can see we are smoothing out our entire volume. Let's go into the VDB smooth. I can change the filter voxel radius to really exaggerate the smoothing. I can change the operation, change this to Gaussian. We have these different types of algorithm for applying the smoothing, and after conversion, and here as you can see we have this very smooth conversion of our geometry. And let me activate smooth wire shaded to see, and here you can see we have, it is an polygonal piece of geometry, it's not a volume, and it is very smooth, and it's a very complex piece of geometry. And we also have some other operation. So after the VDB combine we can add the noise in here. So if I type the volume noise, let's add a volume noise node in here, and here as you can see we have these three nodes. We have the volume noise fog, and we have the volume noise SDF. Because we are working with SDF volume, so let's add the volume noise SDF node. After the VDB combine, I'm going to connect this in here. So what that will do, it will just add the noise on top of this volume. Let me activate this, and here you can see it is using the surface volume, and we are adding the noise in the surface volume, that is correct. And we have this noise, we are using the simplex noise, we have fast noise, we have multiple types of noises. Maybe let's change this to simplex, and in here let's increase the amplitude to really exaggerate the effect. So let's change the amplitude to a value of 1, and I think the value of 1 is too high because, and here you can see it is calculating. I'm going to press escape, but it is actually calculated, but it was taking long. So if the volume is taking long, you can press escape to cancel the operation. But now we have this really weird volume representation. So maybe we need to just change this to a very lower amplitude. Let's change this to 0.2 and let's change this to 0.3. Okay, so we are adding the distortion in our geometry, and now we are adding the VDB smooth node, and VDB smooth node is actually right now it's smoothing out all of our this geometry. So maybe let's change this to mean value, lower down the iteration, and it's breaking. Median value, let me change the different type of algorithm. Okay, I think the median value is working fine. And after the convert VDB, now we have our polygonal piece of geometry. You can use these volumes to actually create your you can model your geometry. That is called the volume based modeling. Now let's take a look at the fog volume. So in here I'm going to create a rubber toy in here, and let's create an VDB from polygon node to convert this into VDB volume. And this time let's use the fog VDB. So let's uncheck the distance VDB and enable the fog VDB. And in here I'm going to lower down the voxel size to create a more high-res representation, more high-res volume. And here as you can see we have this fog type volume, and we can use this fog to create volumetric type of effect, for example the fog or clouds. So maybe let's turn this rubber toy geometry into fog, and right now we have this very smooth representation or this very smooth looking rubber toy, and I can adjust the density to create a more thicker volume. Right now our volume is thin. To actually visualize this as a thin, we can actually create a volume visualize node. So let me add a volume visualize, and let's connect this. And please note that this volume visualize is just for the viewport visualization only. So if you want to actually adjust your visualization at render time, we can make these adjustment in our actual material. So later when we are going to render this inside of Solaris, we have the material, so we can actually adjust the same setting at our material level and we will get the same result at render time. The volume visualization is only just for the viewport visualization. So in here I can increase the density scale. So let's increase this, and here you can see we are multiplying our density volume value to actually create a thicker volume. And in here let's maybe calculate the ambient occlusion, and for that I'm going to enable the ambient shadow. So let's enable this, and by enabling the ambient shadow we are basically creating the ambient occlusion, and we can change the ambient occlusion color by enabling the send ambient color. And onto the occluded color I can change this to anything, for example the blue because it's in a cloud, or maybe let's desaturate this value, and I can increase the shadow scale to create a more thicker type of our shadows, or maybe let's change this to default black, and let me lower down this shadow scale, and it's just the viewport visualization. And let's increase the density value, and let's maybe add some noise into this volume. And for that, after the conversion, let's add a volume noise by typing volume noise, and this time I'm going to use the volume noise fog node. So let's add this and connect this in between, and let me view this, and I'm going to actually view this with my volume visualization. So let's go into the volume noise fog, and in here we can adjust the parameter of our noise. Let's play around with the amplitude, and right now I cannot see the effect, so maybe let's change the range. It says to positive range, let's change this to 0 centered, and now I can increase the amplitude, and here as you can see we have some cutoff. And onto the element size we can adjust the frequency of our noise. So maybe let's lower this value down to 0.1 to create a high frequency noise. And here you can see we have some breakups going on. Maybe let's increase the element size to 0.5, and I'm going to create this bigger type of for this noise. Let's adjust the amplitude, and we can actually also animate this noise as well. So if I enable the animation, let's enable this, and let's enable our play bar. And if we hit play, and here as you can see, we also have the animation. Let me stop this and go back, and you can adjust your animation speed. Let's enable this menu, and here we have the pulse duration. So if you increase the pulse duration, you are creating your animation to a slow-mo. So we will have a slow evolution of our noise. And same way, if I were to decrease the pulse duration, let's say value of 0.1, and now we will have the faster evolution because we have shorter pulse duration. So we will get a very fast animation, and here you can see. That's how you can control your animation. Let me uncheck this. And in here we can adjust the offset of our noise. And after that, let's add another noise to layer different types of noises. So for this one, I'm going to just duplicate this volume noise and connect this after that. And for this one, I'm going to create a more high frequency noise. So in here, I'm going to just lower down the element size to a value of 0.1 to add more smaller breakups. And onto the offset, I can play around with the offset value. Let's zero out to change the offset to its default values. I can play around with the amplitude, and after that I can just keep layering down these noises to create this my cloud like looking shape. So that is the difference between the SDF volume and the fog volume. So now in the next lesson, let's create the clouds by using these VDB volumes, because right now we are using these just basic volume noise node to add some noise in our fog volume, but we also have some dedicated nodes for creating the clouds, and we are using the fog VDB for creating the cloud. So let's take a look at that cloud creation workflow in the next lesson.